All right, so in assignment number 8, we're going to be talking about complex fractions. Complex fractions are fractions within fractions. And so let's go ahead and there's just 4 problems that we have in this video, but we're going to take a look at them one at a time. Each one gets a little bit more difficult. So take a look at number 1 first. If I have 1 over x over y, well, that's the same thing as writing it as 1 over x divided by y. Well, that's the same thing as 1 over x times the reciprocal of y, which is 1 over y. And so if I multiply those together, I'm going to get 1 over x times y. And so if I simplify this complex fraction, it's 1 over x times y. This is now no longer a complex fraction because there's no fraction within a fraction. Here we had a fraction that was part of our numerator, and that's what makes it a complex fraction. So let's take a look at this example. What I want to do is get this to be one simple fraction. And so I'm going to keep the 3 as the numerator, but I'm going to have to subtract 1 minus 1 over 2y. Well, I'm going to change the 1 to 2y over 2y minus 1 over 2y. That way I can write this as 3 over 2y minus 1 over 2y. Well, that's the same thing as 3 divided by 2y minus 1 over 2y, which is the same thing as 3 times 2y over 2y minus 1, because I'm multiplying by the reciprocal. And so if I multiply, 3 times 2y is 6y over 2y minus 1. It's going to be tempting for some people to simplify the 6 and the 2. You cannot do that because the 2y is connected with the 2y minus 1. And so I just have to leave it as 6y over 2y minus 1. We do have some restrictions. The y could not equal a half, because if it does, 2 times a half is 1 and 1 minus 1 is 0, and we're dividing by 0. The other thing that y cannot be is y cannot equal 0, because then I have a denominator of here that's 0. Anywhere in the process, I cannot have a denominator that's equal to 0. If I do, that's a restriction. Let's move on. Boy, this one looks a lot more complicated. But I'm going to work on the numerator first. And so my common denominator is going to be xy. So I'm going to multiply the first fraction by y, which means this is going to be 5y minus, I'm going to have to multiply the second fraction by x over x, so it's going to be 2x, over my common denominator, which is now xy. So I'm just going to put it as xy. Over my numerator, so again, I'm going to have a common denominator of xy, so I'm going to have negative 4x minus, I'm going to multiply the 6 times, that's y, not x, that's a y. I'm going to multiply the 6 times x, and both of those are over xy. So I'm just going to put it over xy. Well, that means that I'm going to have 5y minus 2x over xy divided by the denominator. But what I'm going to do is multiply by the reciprocal of the bottom fraction. So it's minus 4x minus 6y. Oops, I mixed those around. Let me fix that here before I go on. This is going to be a y here and an x here. So this is the y and this is the x. All right, so now my xy's cancel, and in the numerator I have 5y minus 2x over, in my denominator, negative 4y minus 6x. I could factor a 2 out of the denominator, but that's not going to give me anything to factor out of the numerator. I could maybe write this, if I multiply the top and the bottom by negative 1, this would be the same thing as if I wrote it as negative 5y plus 2x over 4y plus 6x. That would be the same thing, but either one of these would work and give you the correct answer. One more problem here. Let's take a look at this complex fraction. This is about as complex as it's going to get. But here again, I want to make sure that I have a common denominator because I'm going to focus on the numerator first. I want to add those together. And so I have an x here, and I have an x plus 1 here. Well, that means over on the left part of this fraction, I'm going to multiply by x plus 1 because that's part of the denominator that I don't have, which means I'm going to take x minus 2 times x plus 1. And that fraction is going to be over x times x plus 1. Then I'm going to subtract 2. I'm going to have to multiply this by x and the top by x. So it's going to be minus 2x over x times x plus 1. So you can see my common denominator is x times x plus 1. Well, let me go ahead and finish this. I'm going to just kind of work over here on the left. I'm going to FOIL this out. X times x is x squared. Then I'm going to have plus an x minus a 2x and minus a 2. That's going to give me x squared minus x minus 2. But then I'm going to have minus the 2x from this 2x here. So in all, I'm going to have, as the numerator, x squared, negative x and a negative 2x is a negative 3x minus 2, over my common denominator, which is x times x plus 1. All right, that's the numerator. Now let's focus on the denominator. So my common denominator is going to be x minus 1 times x plus 1. Well, that means I'm going to multiply the first fraction by x plus 1. Well, that's going to give me 3x plus 3 over the common denominator, which is x plus 1 times x minus 1. Then I'm going to multiply the second fraction here times x minus 1. Well, that's going to be minus, and I'm going to write it as x minus 1. 1 times x minus 1 is just x minus 1 over the common denominator, which is x plus 1 times x minus 1. So let's just take a look at the numerator here. I have 3x plus 3. If I distribute this negative 1, I'm going to have minus x plus 1. That's going to give me 3x minus x is 2x. 3 plus 1 is 4 over my common denominator, which is x plus 1 times x minus 1. Well, at least now I have just fractions. I'm not adding anything in there. What I'm going to do next is I'm going to take the x squared minus 3x minus 2 over x times x plus 1. I'll write it as x plus 1 times x. And I'm going to multiply it times the reciprocal of the bottom. So I'm going to in the numerator, I'm going to have x plus 1 times x minus 1. And the denominator, I'm going to have, I'm going to write it as 2 times x plus 2. So what cancels out? Well, first of all, let's see if I can factor this. If I can, that would be great. Is there something that multiplies together to give me negative 2 that adds up to a negative 3? And I don't think there is. Negative 2 times positive 1 would give me negative 2, but it wouldn't give me negative 3. So this can't be factored at all. But I can do this. X plus 1s, those cancel out. And I think that's going to be it. So in factored form, I'm going to see if I can squeeze this in here. In factored form, I'm going to have x squared minus 3x minus 2 times x minus 1. That's the numerator. The denominator is going to be 2x, 2 times the x times x plus 2. And that's as simple as I can make it. Again, I will have restrictions. X cannot equal 1 or negative 1 because it'll make those denominators equal to 0. It can't be 0 because then this denominator would be equal to 0. And it can't be negative 2 because if it's negative 2, then this would be 0. And anywhere in the process, I cannot have a denominator that's equal to 0. And so that's what the answer is to number 4. Hopefully this all makes sense, and we can go over your questions tomorrow that you have in class. We will see you then.